Okay, so today we are talking about the volume of pyramids and cones, and we are going to start off by defining a pyramid, and that is your base is a polygon. So let me do this in pencil, hopefully you can see it. So if you have a triangular base, by going back and erasing some of these things. Okay, so you would have a polygon base, and then all the faces of the sides would meet at one point. Okay, you're going to meet at one point. So you could have a triangular pyramid, and so when it says triangular pyramid, that's telling you that the base is a triangle. You could have a rectangular or a square pyramid. Okay, so again, you have your base, and then all the faces of your sides are also polygons that meet at a point. So let's say that this is a square pyramid. Okay, and then for cones, same idea, but instead of a polygon for a base, you have a circular base. And again, meets at a point. Okay, so this would be a cone. So why do you think, this is a question, so why do you think that pyramids and cones are taught together? So pause it if you need to. Why do you think that pyramids and cones are taught together? The answer would be because they, again, just like the prisms and cylinders, you are using the same formula. And they all, in every situation, they go to a point. So the volume of these items is 1/3 the area of the base times the height. So this should look very familiar. We have already done this formula with prisms and cylinders, but now we're just doing 1/3 of that, and that is because you are going to a point. So 1/3 the area of the base times the height. So if you wanted to be more specific, the volume of a cone is 1/3. The area of the base is a circle, so that is pi r squared h. But if you just remember the one formula, it's going to work. Okay, so let's do some examples. Label this as example 1. So we are going to find the volume. I'm missing some of my dotted lines. Technically, this should be dotted, and this should be dotted. Okay, so we have a triangular pyramid. I'm going to say that this side is 8 and 8. And then I'm going to say that the height of the pyramid is, we'll make it 12. So using the formula, volume equals 1/3 area of the base times the height. Area of the base is a triangle, and I know that the formula for the area of a triangle is 1/2 base times height, and the height of the whole pyramid is 12. So 1/3, bring that down, 1/2. So again, I'm working on the area of the base, which is a triangle. The base and the height are the two sides that form the right angle. So I have an 8 and an 8 times my 12. And I would just put this all in my calculator at once. I'm probably going to do a little simple function first, just for my ease of putting it in the calculator. So I have 4 times 8 times 4. So I have the volume equals 128. Volume is units cubed. Example 2. If we are dealing with a cone, okay, so we're going to kind of step this one up a notch. I'm going to tell you that the diameter is 20 inches. Okay, so the diameter is 20. Volume equals 1/3 area of the base times the height. And the base shape in this case is a circle, so it's pi r squared h. So 1/3, pi doesn't change. Radius is what? The diameter is 20, then the radius is going to be 10. We're going to square that. And I'm going to tell you, I'm going to introduce this piece. Okay, this is called the slant height. And I'm going to tell you that the slant height is, let's say, 16 inches. Well, in this formula, I don't need the slant height, I need the height. So what I'm going to do is I am going to take this little triangle right here and pull it off to the side so that you can see what I'm doing. So the slant height is 16 and the radius is 10. So do I have enough information to find the height that I'm looking for? And the answer is yes. So whenever you are looking for a missing side of a right triangle, you should be thinking about the Pythagorean Theorem. So a h squared plus 10 squared equals the hypotenuse squared. I'm going to do a little bit of shortcut. And I get h squared to equal 156. I'm going to square root that in my calculator. And I get the height to be about 12.49 inches. So now I have enough to find my height, 12.49. So I would chuck all of that into the calculator. So 1 divided by 3 times pi times my 10 squared times my 12.49, and I get a volume of 1,307.95 inches cubed. Okay, so we introduced a lot of different scenarios on example 2, starting off with not having the height given, and starting off with giving you the slant height, and then having to break this down using the Pythagorean Theorem. So there's lots of little things that you're going to be finding. One last, I'm not going to actually complete this example, I just want to give you a heads up. You might have what are called composite figures. And what composite figures are, it's taking two shapes and well, more than one shape and putting them together. So for example, if I had a cylinder with a cone on the top. So in order to find the volume of this whole figure, I would do the volume of the cylinder, and I would add the volume of the cone. Or maybe I would have a prism with a hole drilled in it. So for this one, I would do the volume of the prism. Because I'm taking that centerpiece out, I would subtract the volume of the cylinder. And I do recommend writing these two things out. It gets you going and it keeps your work very organized.